All right, so input devices form the interface by which field devices are connected to the controller, yeah, to the PLC. So right here we got a normally open switch right here, a push button, a limit switch, and so on and so forth, yeah. Now uh, see where is this guy connected to, guys? This guy. So this is 0, yeah, input 0, this is input 0, this is input 1, yeah. Okay, see, this is input 2, this is right here, I:1/0, this is here he connected to, yeah. He is connected to 0, 1, 2, 3, 4. So how would you write that? I:1/4, yeah. Make sense? We got this switch right here, the limit switch. He is connected to number 8, I:1/8. What does it mean? Input card 1, and card 1 I got connection 8. The CPU is going to check that connection for whatever program you has written, yeah. So if you are saying if your program is I:1/8 and then turn on O:3/8, so the CPU is going to check this guy I:1/8, yeah. It's going to check it. If it is on, then he's going to turn on O:3/8. Make sense? Go ahead. What is it? A 3/8. So input, so let's say this is card 1, yeah. So card 1 and card 1 we have the output 3/8. This guy, that would be another card's output, that would be third card, output third card, yeah. So that would be output and card third connection number 8, yeah. So output cards, so right here is the output card, yeah. So depending on the status of the input, if the status of the input is on, then possibly depending on your program, these outputs right here could turn on. So you got a motor coil, yeah, that we will talk about. You got a solenoid, looks like. You got a red and yellow light, yeah. So these are outputs. Here is an example right here, a screenshot of a PLC program. Right here, this is how you can design the program. So right here is your normally open, normally close. And if you see, what is this? This is, this is, and also, you guys would see and or and those logics as we go, okay. So this has to be true and this has to be true, let's say for this guy to be true, yeah. This or this has to be true for this guy to, if this guy is on, then you can go this way to turn this light on. If he is off and this is on, then you can go this way and turn on the light, yes. Look at this basic program, okay, mixer process control problem. A mixer motor is used to automatically stir liquid. So here is a liquid and here you got the mixer right here. So this motor turn on and you might have sugar there or whatever is there, you can mix them, yeah. Automatically sit and wait when the temperature and pressure reach preset value. Make sense? So this liquid is heated to certain temperature and there is a certain pressure. See, this guy is measuring pressure, right here is measuring temperature. So if those conditions are met, then what we want to do? We want to start the mixer, yeah? And to start the mixer, they say manually. So you have, you would have two screens. So one screen, let's say you want this liquid to be at 70 degrees, yeah? And you want the pressure to be, let's say 10, whatever unit you want to use. Just for now, let's say 10, yeah? So if the screen says those two values, yeah, then we are going to turn on a switch which will turn on this mixer. Yeah? So the program right here is what? You got a pressure switch. This is the pressure switch. You got a temperature switch. See, temperature switch and the pressure switch, both of them has to be true, yeah? Both of them has to reach to that value where we want to reach, yeah? And if those two are true, what's going to happen? Yep, the coil will energize and the mixer will start run, yeah? Now, how else we are starting? Beside that, can we start this mixer? Yeah, we can do it manually, yeah? So either these two has to be true, or we can start and stop it manually. And you know why? That's a good that's a good thing, because maybe this guy is stuck and maybe this guy is stuck and this guy is going forever, yeah? So we will have a manual switch right there. We can, you guys getting it? That is a very basic PLC program. Very nice right here. So do you guys see? I mean, it looks kind of blurred. But here is your pressure switch, here is your temperature switch, and here is your input push button. Those are all inputs to the PLC. And what is the output to the PLC? It is the mixer, yeah? Right here, input, 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 yeah? And where is this input connected to? He is connected to I:1, to the input, to the connection I:1/0, let's say, yeah? Or 1/1, so he is connection 1. Okay, and I:1/1. In card 1, he is connected to what? To connection 1. In card 1, he is connected to connection 2, yeah? The CPU is going to check connection in card 1, yeah? He is going to check the connection in card 1 and connection 2, yeah? Makes sense? If they are true, then the motor is going to turn on, yes? The mixer. Or he is going to check what? I:10, connection 0, which is just a push button, yeah? It's this guy right here, see? Right here, no, it's not there. So 1-3 right here, 1-3 was right here. This guy right here, yeah? You see it now? Making sense or no? So this is your whole program right here. And do you guys see that this right here is a real world device? Yeah, this is real world device. And in between we have this logic, yeah? So the CPU is looking at the RAM, at the space to see if the thing is on or off. And depending on the status of those inputs, the output is on, yeah? Let me make this program quickly in